All right, so what's the GCF of number 1? So funny.
I just wanted to hear myself. It was hot. Yeah, you made a little bit.
So, is the inside stuff factorable? Are there factors of -3 that will ever add up to +5? No, so you're done. If this case occurs, don't make it harder on yourself. What about in number 2? What's the GCF here? So that leaves behind?
3x minus 7.
Excellent. So, go ahead.
Because it only has one x and a 3, so that means that 1x and a 3.
Good.
If you divide it, you just subtract it.
Yeah. Okay, so let's talk about what's new today versus yesterday. Only thing we're adding today is that we are solving equations instead of factoring expressions. So what's the difference between an equation and an expression? What's the difference between an expression and an equation? Examples 1, what? Exactly. So like example 1 and 2 on the bell ringers are expressions. There are no equal signs. The 4 examples on the back have equal signs, therefore they're equations. So you can think of the word equation as having equals in it. Today we're going to talk about the zero product property, and this is a property you've probably heard of, but you kind of tend to forget that you're using it. So what the zero product property says is that if the product of 2 real numbers is 0, so meaning if I multiply 2 things together and I get 0, then one of those 2 numbers is 0. So if I multiply 2 numbers together to get 0, one of those numbers has to be 0. If I multiply 2 parentheses together and it equals 0, then one of those sets of parentheses has to be 0, or both have to be 0. So let's apply that property. So you have the example 2a plus 4 times the quantity a plus 7 equals 0. So the zero product property says a times b equals 0 if a equals 0 or b equals 0. Well, we're going to treat this piece here kind of like the a. We're going to treat this piece here like the b. So what that means is that either 2a plus 4 has to equal 0 or a plus 7 has to equal 0. So solve for a. And hopefully, see, here's where the solve me maybe song came in. You're solving for a. So you either got a equals -2 or a equals -7. Both of those would act as the roots of this quadratic. Sometimes when we factor, we get confused and we forget the step that we should take to get to our solution. So what I've done is I've sort of typed out a 4-step process that will help you solve by factoring. The first thing that has to always occur when we solve by factoring is that it must equal 0. If what you're trying to factor does not equal 0, then you cannot correctly factor it. If what you're trying to factor does not equal 0, you cannot correctly factor it. So we have to set the equation equal to 0. Then we factor the equation, and we factor it using that magic X technique, where you put the first and the last numbers multiplied together. So in standard form, you have ax squared plus bx plus c. So what that's saying is you would take the first and the last number, you multiply them together, and they have to add up to the middle number. So we use our magic X. Then we do the GCF part with what we found for the magic X. Then the new part is to solve what we found as our factors. So we're going to set each one equal to 0 separately and solve for the variable. So I didn't put them on your paper, but what I did is I did example 1 using those 4 steps. So as I go through example 1, I'm going to have the type step with my work. So in example 1, we have 3x squared minus x equals 10. Does this pass step 1? Is that set equal to 0? No, it's currently set equal to 10. So what I have to do is I must subtract 10 from both sides. God bless you. So now my equation becomes 3x squared minus x minus 10 equals 0. So I've completed step 1. I set the equation equal to 0. Step 2 is to factor this newfound equation. So in order to factor it, I have to do my multiplying. So I'm going to form my magic X. So my magic X says I multiply A times C, or in this case, 3 times -10, to get me a -30 up top. My B term is -1. So I need factors of -30 that sum to -1. So what do you know what numbers multiply to give me -30 that are 1 apart? Yeah, -6 and +5. Now we select the negative to be the 6 and the 5 to be positive because their sum is negative. So now replace the -1 with the -6 and the -5. So it's this line right here. We split that middle number, that -1, and we replace it with the -6 and the +5. This is the case where you always want to put the negative factor first, because it will make your factor by grouping easier. If you rate -6 and +5, you don't have to worry about pulling out a negative number. So GCF of 3x squared minus 6x is 3x. GCF of 5x minus 10 is 5. Inside parentheses match. So my factors are 3x plus 5, x minus 2. Here's the new step. Set each one equal to 0 separately and solve for x. So you got x minus 2 equals 0, and through x plus 5 equals 0. So your final answers are x minus 5/3 or x equals 2.
How many times have we
And
trying to get like this back? Yeah, no, Marco.
Okay. So that's pretty much it. We're going to follow those same 4 steps to do every problem we do today. So step 1, is the function equal to 0? If not, set it equal to 0 and rearrange it in standard form. So you always have to be in ax squared plus bx plus c equals 0 form. So that means that this term right here is my bx term. I don't want to put it after the 27. I want to smush it between the x squared and the negative 27. So I'm going to subtract 6x, but I'm going to smush it between the x squared and the negative 27. So I get x squared minus 6x minus 27 equals 0. Now, write this in your magic x. The first times the last gives negative 27. The middle is negative 6. So what are some factors of negative 27 that add to negative 6? What do you think, Matt? Good. So again, I get one negative and one positive. So that means I want to write my negative first. So we're going to replace my negative 6 with a negative 9 and a positive 3. So I get x squared minus 9x plus 3x minus 27. Go ahead. Group the outside, group the inside. So you get x minus 9 plus 3, x minus 9. So you get x plus 3, x minus 9. Now if you look, I kind of forgot to do something along the way. What did I forget to do as I was writing this? What did I leave off in one of my steps? What are all of these supposed to be set equal to? So if you forget it, just go back at the end and fill in your equal zeros. So x plus 3 has to equal 0, and x minus 9 has to equal 0. So x is negative 3 because we subtract 3 from both sides, and x is positive 9 because we add 9 to both sides. Negative 3 and positive 9 are the roots or the solutions of this equation. So what that means is if I put either number in for x, I get 0. Is this set equal to 0? Yeah, so I'm going to add 5x to both sides. Smush it in the middle. So you get 2x squared plus 5x minus 3 equals 0. I'm going to magic exit. So 2 and negative 3 give negative 6. But negative 6 factors have to equal a positive 5. So if it's a negative multiple and a positive addition, go ahead. So a negative times a negative would give you a, so I need it to give me a negative.
How are you supposed to use the negative 5?
It's a positive 5.
How are you supposed to do the positive 5?
Because it's negative 1 and positive or negative 6. Because
Oh, okay.
So like since this is positive 5, I'm going to pick a positive 6 and a negative 1. Because 6 minus 1 gives me 5. 6 times Remember, you always want to write the negative factor first. So I want to write negative 1x plus 6x minus 3 equals 0.
Well, what if they're both positive or both negative?
Yeah, it doesn't matter. Pull out a 1x, leaving 2x minus 1. Pull out a 3, leaving 2x minus 1. So you get x plus 3, 2x minus 1. Now you set each equal to 0
Wait, how do we get the x plus
from the outside.
3? Oh, okay.
So here we subtract 3, and we get x equals negative 3. Over here, because of the 2 on the x, this is actually a two-step equation to solve. So you have to add your 1 to both sides, and then you have to divide by 2. So you get x equals 1/2. Okay. Step 1, set the factors equal to 0. Done. Step 2, factor the equation. So what goes in my magic x on the top?
Wait. No, because it's
You do the
a
last
0.
one.
Yeah, it's a 0. Because it's nothing.
So there's like an imaginary plus 0, right? So it's 2 times 0, which is 0, and they have to add up to. So what two numbers are going to multiply to give you 0, but add to give you 8?
0 and 8.
Yeah, right? You have to pick 0 and 8. Again, it doesn't matter what order you write them in when you do your grouping. So you could do 2x squared plus 0x plus 8x plus 8. Oh, sorry, plus 0 equals 0. So that sort of seems goofy, right? You factor by grouping, you could take out an x, but that just leaves 2x. Here, can't really take out anything but a 1. That leaves 8x. So what's wrong with this problem? Why isn't it working?
Wait, how can you take out a 1?
Yeah. But
Yeah.
you don't
Well,
have
0 times 1 is still.
Wait, but there's not even a 1. So
No.
how can you
Wait,
take out
are
a
you
1?
pulling out the 1 from the 8 or the 1 from the 0?
Both. That's what I'm saying. Like, why isn't this working? What type of problem is this?
Unfunctional.
No, not. It's still factorable.
Factorable.
So let's go
It doesn't
back.
work.
What?
It just doesn't work.
No, it does. What should I have done that I didn't do that I always tell you is step 1?
There's no 0. I mean 6. C. There's no C.
Well, yeah, but what do I always say is step 1 when you're factoring? And what didn't we, like, had I GCF'd this?
Did you know you did that?
You want me to?
You can leave it and then just write yourself a little note and say, this is why you do the GCF first. Because now, look what I have. I have 2x equals 0 and x plus 4 equals 0. So x equals 0 or negative 4.
Natural
Switch.
roots.
Yes.
Bada bing, bada boom, bazinga. It's a good show.